Assalamualaikum warahmatullahi wabarakatuh and good evening. So my name is Muhammad Zuhelmi bin Muhammad Zuraidi. My metric number is DE190153. So I will present about my PSM2 project, which is deep learning method for flood detection. First, for the introduction, flood, one of the most devastating natural calamities, have wreaked havoc on highways, homes and crops, and has been the subject of several research. At least once in a year, some of the regions with low-lying area possible to receive flood twice or even more in a year. In some circumstances, and during the monsoon season, flash may happen, leading loss of human life and damage of settlements. On the other hand, the machine learning and deep learning have made significant advances in image classification. So for the problem statement, the economic life and loss caused by the flood disaster is because the citizens and manufacturers have not received warning on disaster risk, and the government has not received information with agency. It is imperative that government should identify the efficient methods to overcome this problem to reduce the losses. However, some of the existing systems can be expensive and complex in the implementation when testing the simulation network in a real-world setting. So for the objective, I want to propose a deep learning system for early flood detection. Next is to explore the feasibility of pre-trained network for flood detection, and the last objective is to evaluate the performance of trained system for flood detection. So for the scope, the deep learning model trained based on image data obtained from public sources such as Kaggle and Self-Collect. The project explores pre-trained network available in MATLAB, namely AlexNet for prediction purpose. And the last scope is the performance of the system evaluated in terms of prediction accuracy. Okay, so this is the methodology for my project. So we will start the system with data collection for flood and non-flood image. Then it will input the image resize to 277 times 277 times 3, which is for RGB. So next it will go through the pre-processing, segmentation, feature extraction, and goes to classification if the classification had been done, and it will end the system. So for this is the setup for my deep learning system. So the type of deep learning that I will use is AlexNet. The initial learn rate I will use is 0.001, meaning batch size 5 and 10. For the epoch, I will use 10, 20 and 30, and for the data splitting, I will use 70% training and 30% validation. So for the result and discussion, so this is the result from the simulation that have been run. So this is the image had been classified as non-flood and flood image. So as we can see, total the image is 36. So this is the binary classification for my prediction purpose. So this is the result that I've been collect from the simulation. So as we can see, the best performer will goes to batch 5 with 20 epoch because the validation and training accuracy is 100% with the time taken 1499 seconds. So for the batch size 10, the best epoch will go to the 13 because that is the highest validation and accuracy training accuracy among the other two batch epoch. So for the confusion matrix, as we can see, as same as the result before, the best performance goes to 20 epoch with 5 batch size because the value of accuracy is 1, precision 1, sensitivity 1, and specificity is 1. So same as the before also, for 13 epoch with 10 batch size, the accuracy is higher, and the precision, sensitivity and specificity also higher than other two. So for the discussion, small batch size can give a negative impact on performance system. It also vulnerable to data randomness. So that's That's the reason why I chose 5 and 10. So higher batch size can lead to more accurate system, and the setup need to balance because to avoid overfitting, cross validation and regularization. So the increased number of batch size affected the time taken to complete the process. So as we can see in this table, when I increase the number of epoch, it will increase the time taken. So for this table, high sensitivity will be able to property identify many positive example with low proportion negative. So with high specificity have low rate of false positive and able to accurately identify many negative cases. And the last one is high accuracy, which is high accuracy can detect high example of positive. As example, the picture have been qualified as positive and low number of false positive errors. So for the conclusion, according to the objective state, all the objectives successfully achieved because the machine vision had been built which AlexNet was used to detect flight. Other than that, the exploration and discover about other deep learning method from the structure of the system and the effectiveness through the experiment in the article and journal had been done. Lastly, based on the result obtained, the best evaluation of the system performance can be achieved with no misclassification, with the less misclassification from the picture. Okay, so from the recommendation for future work, for the future works, I will include adding GUI to make the implementation more user friendly and into insert alert system to increase the effectiveness of flood detection system. The enlargement of well annotated dataset also can help to achieve better accuracy so that the system can learn and have potential in real application of flood detection. Lastly, a system with fast computing also will help to speed up the training process. So that's all from my presentation for my project. Thank you.